Okay, this topic will be related to the ascending pathways of the spinal cord. I like to highlight at the beginning that we have the corresponding pathways from the head related to the cranial nerves, which won't be seen in my drawing. We have three major sensory qualities related to the spinal cord pathways. One is the protopathic. This means the more primitive touch sensation, the so-called crude touch or superficial touch, when we are not able to recognize the object. We have a thermoreception, so we are able to detect the warm and cold, and the nociception, which related to the pain sensation, and the reflexes, what we described earlier, related to this. The more complex sensory detection is called epicritic sensibility. It means the two-point discrimination in time and space. So, for example, when we detect, when we are able to distinguish between two stimuli in time, such as the vibration, this is related to the epicritic sensibility, or when we are able to detect and recognize an object without seeing it. So, for example, the digital or rectal examination, what doctors use later in the clinical practice, that is typical example for this. And the third one is the so-called proprioceptive sensibility. When we are able to detect the body posture, the position of the joints and the muscle tone, the corresponding reflexes were mentioned earlier. The proprioceptive otherwise has two options. Has a so-called conscious part, that is carried by the epicritic pathway, that's why I added to this, and we have the unconscious option, which is a separate pathway, and this will be a bit different from the others. The epicritic, including the conscious proprioceptive and the protopathic, will send input to the cortex to be conscious stimulus, and this way we have to use at least 3 neurons, usually 3 neurons. In case of the pain we have a more complicated and more neurons will be included, but we can say 3 neurons. And the rule is that the first order neuron is always in the dorsal root ganglion at the level of the spinal cord, and the third, which is the last subcortical center, should be always in the thalamus. So this way the first and the third sites are the same, and the difference will be in the second, because can be either in the spinal cord or above in the medulla oblongata, but I will make a schematic drawing about that. So in these two cases we have 3 nerve cells, 3 neurons, 3 neurons, or more in pain. Pain is always a bit more complicated, as earlier I mentioned. But in case of the unconscious proprioceptive input, we have only 2 nerve cells, 2 neurons. So let's see the first one, the protopathic sensibility. If this is the spinal cord, the first order neuron coming from the site of the stimulus, dorsal root ganglion nerve cell is the first order neuron, and this enters the spinal cord at the same segment, or in case of the pain, it ascends a few segments or descends a few segments first and then enters. Usually it terminates in the more superficial part of the posterior horn, but at the end the spinothalamic tract will be activated, which may originate from different rexed laminae, which is species dependent. So that's why you may find different rexed laminae for the start points of the spinothalamic tract. We accept almost everything with the exception of the second and maybe the third, which are mostly interneurons in the substantia gelatinosa Roland, and the ninth, which is for the large motoneurons A alpha and A gamma type. So with the exception of these, basically from all the other parts of the gray matter of the spinal cord, we may have start point of the spinothalamic tract. But in spite of this, I will label the most classic, which comes from the fourth layer of the rexed lamina. If you remember in the histo slide of the spinal cord, in the posterior horn, this was the first rexed lamina, the fourth one, where we have the largest nerve cells in the posterior horn. And from here we have a pathway which then ascends in an arch, partly in the anterior funiculus or column, partly in the lateral funiculus or column, depending what kind of input is carried by this. But this is called spinothalamic tract. We have anterior for the touch and lateral for the pain and temperature detection. And this pathway, maybe I don't terminate this, ascends contralaterally. And you see, I forgot to mention that the second order neuron crosses at the level of the start point. This is called anterior wide commissure and ascends contralaterally in an arch, as I told you, up to the thalamus. So the third order neuron will be in the thalamus. This is the thalamus. And we have a special nucleus for this purpose, the VPL, the ventral posterolateral nucleus. And from here we go up to the cortex. We don't count the cortical neurons in the pathway, so that's why we don't have 4, just 3 nerve cells. And it goes up to the Brodmann 3, 1, 2, which is the primary somatosensory cortex. So as we summarize this, it includes 3 nerve cells. The second order neuron crosses. Let me label this second order neuron. I label now in the posterior horn the fourth rexed lamina, can be the first, as I told you, the rest of the posterior horn, the intermediate gray matter, or even the commissure nucleus can be the site of the second order neuron. We have the crossing in the anterior wide commissure, and contralaterally, partly in the anterior or in the lateral funiculus, we have the spinothalamic tract up to the thalamus, where we have the third order neuron. And from there we have a connection directly to the primary somatosensory cortex, Brodmann 3, 1, 2. This uppermost part otherwise will be called superior thalamic radiation, or will be included in the superior thalamic radiation. In case of the pain, however, we have several other differences. I don't want to show this. In case of the incoming central fiber, as I told you, it ascend or descend a few segments, then enter, and then terminates in the second and third rexed lamina of rexed in the substantia gelatinosa, and then it runs to the, let's say, fourth rexed lamina, where the spinothalamic tracts, and it ascends laterally then. We may have other options, not only the VPL nucleus of the thalamus. In case of the pain, we are able to go to the so-called intralaminar nuclei, I will mention later in the lecture, and from there we have another projection, not only to the primary somatosensory cortex, Brodmann 3, 1, 2, but from the intralaminar nuclei and through the dorsal median nucleus of the thalamus we are able to go to the prefrontal cortex, cingulate gyres for the emotional sensation of the pain. That is quite complicated. We have other collaterals to the mesencephalon from this tract, so it is the spinal mesencephalic tract. We have to the reticle formation and eruption, and via this we go up to the thalamus, that is the spinal reticulothalamic tract. We have direct input to the hypothalamus to have vegetative reaction in case of pain, for example. That is the spinal hypothalamic tract. I don't label these, you don't need to know these for this simple protopathic sensibility pathway. So this is one. Start point is from the mechanoreceptors or proprioceptors, and the thickness is much bigger, so can be 1A or 1B, depends whether it's muscle spindle or GTO related proprioceptive input, the conscious part, or can be type 2, even from the muscle spindle or from mechanoreceptors on the skin. But this is a much thicker and faster conduction this way. This is again the first order neuron. As I told you, the location will be the same. But in case of this, doesn't form synapse at the level of the spinal cord. It ascends ipsilaterally to the second order neuron, which will be the cuneate or gracile nucleus in the medulla oblongata. We saw the corresponding tubercles laterally and inferior to the rhomboid fossa, and from here the secondary neuron will cross and ascend to the thalamus, again the same area, VPL, ventral posterolateral nucleus. So here we have the third order neuron again, and the cuneate and gracile nuclei are the second order neuron. And as you see, this is the site of the crossing now at the level of the medulla oblongata, where the second order neurons are located. And this pathway is quite famous, called medial lemniscus. Medial lemniscus. The crossing is called lemniscal decussation. Or arcuate fibers. I forgot to label here the crossing, I put it here, anterior, white, I mentioned already. Sure. So, from the thalamus then we have a direct input again to the primary somatosensory cortex, Zoltán 3, 1, 2, through again the superior thalamic radiation. So if we compare the two pathways or the two systems, we have several similarities. As I told you, the first order neurons are located in the same place, dorsal root ganglion, using different thickness of fibers, and this way the size of the cell will be also different. Otherwise, the third order neuron, the same in the thalamus, VPL, and the same pathway will lead to the destination, Brundtland 312. The difference will be at the level of this location, the second order neuron, and this way the level of the crossing. In the first case, in the protopathic, it is in the spinal cord, that's why the tract is called spinothalamic tract, and it becomes contralateral immediately. In case of the epicritic, the second order neuron is still in the same side, and then and much higher than the spinal cord, so in the medulla oblongata, and then again the second order neuron will cross as the lemniscal decusation and contralaterally ascends to the thalamus as medial lemniscus. That's why we have a title later for the neuroanatomy exam, dorsal column medial lemniscus system. What I want to add to my epicritic center pathway drawing is this, that here we have two options. We have the gol or gracile fasciculus and burdach or cuneate fasciculus, depending on the segments. If we are from the lower limb, from sacral and lumbar region, it is carried by the gracile fasciculus or gol. If we are from the thoracic and cervical, these are more laterally in the cuneate or burdach. Otherwise, we have the corresponding nuclei as second order neuron in the medulla oblongata. The third sensibility quality is the proprioception, and this is related to the proprioceptive reflex and receptors, what we mentioned earlier. Here, if we are talking about the unconscious input, we have only two neurons required, because we don't need to send input up to the cortex. This way we don't need to have a synapse in the thalamus. We have a direct connection from the spinal cord to the cerebellum. So, if I make a drawing like this, again, just schematically, the first order neuron is related to the proprioceptors. And this will be the thickest, as the previous was. 1A from the muscle spindle, 1B from the Golgi tendon organ, and can be type 2, which is also from muscle spindle. And these all are very thick and with fast conduction. The first order neuron is located in the dorsal ganglia, as in the previous cases. The central process enters the spinal cord. Usually it ascends segments upward, what I don't show, and it terminates at the base of the posterior horn, where we have a little protrusion, but otherwise related to the seventh rexal lamina. This is the Clark nucleus or thoracic nucleus or dorsal nucleus. This is located between C8 and L2 or L3, I put it here, so Clark nucleus, between C8 and L3, basically where we have the sympathetic outflow as well, on the lateral side, and from here the axons of the second order neurons go to the superficial and lateral part, superficial and posterior part of the lateral funiculus, and ascends directly to the cerebellum as a posterior or dorsal spinocerebellar tract. So, doesn't cross, it remains ipsilateral and goes directly from the spinal cord to the cerebellum. And send proprioceptive input to the cerebellum, because the cerebellum will play a very important role in the body posture maintenance and also in the muscle tone regulation. That's why it requires to get proprioceptive input. But from the lower limb, not only this pathway works, we have another pathway under the L3 segments from the lower limb as well, which uses another option with the same thickness of fibers. because the origin regarding the receptors will be the same. This goes rather to the intermediate gray matter, the deeper part of the 7th rexal lamina, and we have a secondary neuron in the 7th rexal lamina, the fibers of which cross and ascend in the superficial anterior part of the lateral funiculus as anterior spinocerebellar tract. In this case, the secondary neuron, which is here, is located simply in the hexagon number 7 in the intermediate gray matter. Clark nucleus was in this segment, also part of hexagon number 7. This option uses another nerve cell, or nerve cells, of course, in the intermediate gray matter, which is labeled by hexagon number 7. I labeled here the secondary neuron as in the other figures. So this is a cross pathway. This crossing again in the anterior white commissure, as it was in case of the spinothalamic tract, but it ascends very superficially in the lateral funiculus, not as the spinothalamic, which is a little deeper. And only laterally, the spinothalamic was partly anterior. And ascends up to the mesencephalon, and then descends and approaches the cerebellum where it crosses. So it crosses twice, so that's why the termination at the end will be ipsilaterally. That is quite tricky. So if we watch the simpler version, the posterior spinocerebellar tract, it approaches the cerebellum through the inferior cerebellar peduncle. We studied this in the medulla oblongata. In the other cases, a case where we have the anterior spinocerebellar tract, it goes up and then descends through the superior cerebellar peduncle, and then it crosses again in the cerebellum, so this way it terminates ipsilaterally regarding the origin. These two are from the lower limb. From the upper limb, we have only one pathway, and this is above C8. We lost the significance of the other option. In some textbooks, you may find it as rostral or superior spinocerebellar tract, but this is significant only in those animals who are still on 4 extremities. In human, we stood up, and that's why 2 pathways are related to the lower limbs only. And from the upper limb, we have only one option, the so-called cuneocerebellar tract, which is quite similar to the posterior spinocerebellar. I don't want to put it in my drawing, but this is from the upper cervical segments, which innervate the upper limb. The dorsal ganglia would be the first of them in this case as well. It joins to the cuneate fasciculus to go up to the so-called lateral or accessory cuneate nucleus in the medulla oblongata, and then it goes via the inferior cerebellar peduncle to the cerebellum, again ipsilaterally, and this is called cuneocerebellar tract. This is the only pathway in case of the upper limb in human. As I mentioned in the beginning, we have corresponding pathways from the head, and in case of the proprioceptive, it will be related to the trigeminal nerve. The epicritic will be related also to the trigeminal nerve, having 2 different nuclei. From the lecture, you may remember that the epicritic nucleus of the trigeminal nerve is the principal sensory nucleus in the pons. The proprioceptive nucleus of the trigeminal nerve is the mesencephalic nucleus. But the protopathic sensibility from the face will be related to 3 other cranial nerves, not only to the trigeminal, the facial, the glossopharyngeal and vagus nerve, and they use the same otherwise nucleus, which is related to the trigeminal nerve, or called after the trigeminal nerve, the spinal nucleus of the trigeminal nerve. We will see this topic later.